so yeah, as I said, Tom spoke literally a decade ago, yeah, we, in fairness, we tried to get him back since then. We're delighted he's here tonight, so over to you, Tom.
Hey, thanks. Hello, everybody. Microphone work? Yeah, I hear myself, and that's all I care about. Hi. So I'm here to talk about something that not all that many people in our industry do, which is staying somewhere for more than 10 years. And like, you learn a lot in 10 years. I've learned a lot in 10 years. I'm going to try and concentrate on stuff that I've learned because I was there for 10 years. Because usually you start a job and you're like, what idiot made this stuff? You know, because you get to clean up everybody else's mistakes. But staying somewhere 10 years, you go, what idiot made it? Oh, me. And then 5 years later, you're like, what idiot made it? Oh, me twice. Cool, sweet. So that's mostly what this talk is about. So I'm going to start with a conclusion, so you can all like go home if this doesn't look interesting. So I'm going to go through kind of 5 big areas of lessons. And I've got some examples, some of which are successes, most of which are failures, because I'm much better at failing than succeeding. Turns out that that's quite a lot easier. And yeah, it's about all my mistakes and all the things that I was like, that's a terrible mistake, and then I tried something different. And I was like, no, that was the best way to do it. And the second approach was a terrible mistake. This is what you find. So anyway, hi, who am I? I've been around for quite a while at this point. I had this horrific realization when I was writing these slides that I've literally been paid to do this bullshit for more than half my life at this point. Like, they think that I can make computer words. It's insane. So, for my sins, I have been a DBA, I've been a network engineer, I've been an IP telephony guy, I've been a security tester, both red and blue team side, I've been a web developer, I've been a streaming data engineer, I've been a team lead, I have driven around with a car with a drill bit that big in the back and drilled through people's walls, put network cables through, because you turned up and they asked you to do anything, so I turned up being able to do anything. I've been a large-scale open source projects commentator. I used to look after the web framework that ran iPlayer back in the day. I've been a Google Summer of Code mentor, and I'm a dog parent and a bunch of other stuff. So that's me. Let me tell you a little bit about Yelp. So to avoid confusion, Yelp is not Yellow Pages. It's not Yell. That Yelp is a US company, and to tell you their blurb, Yelp provides a one-stop local platform for consumers to discover, connect, and transact with local businesses of all sizes. So basically, it's a website that sells ads. It is a TLDR. They're a fairly big deal though. Revenue of $1.4 billion last year, which is big company territory. 60 million monthly web visitors, 36 million desktop visitors, 32 million app visitors. I joined back in 2013. At that point, it was $187 million revenue, not $1.4 billion revenue. So that's about 8 times revenue growth in 10 years, which is a pretty big deal. And you know, traffic grew same, if not more. The number of servers we had grew a lot more than 8 times. It's kind of a big deal. And in 10 years, stuff has kind of changed, right? So back in 2013, the term DevOps was a pretty new thing, like about 3.5 years old at that point. We all used to hate the fact that jobs were advertised as DevOps and there were DevOps teams, because in our naivety we thought that DevOps was a methodology or process, not a job role. How wrong we were. We all know nowadays that DevOps is just like security. It's a product that you buy, not a process that you follow. And site reliability engineering, what the heck was that? Like the folks at Google who wrote the book had not even come up with a title for the book at that point. So we had no idea what site reliability engineering was. And I still have scars on my fingers from the Gen 60 HP DL360s. Those things, every single time you opened one of them, you ended up bleeding. And every single time you opened one of them, you ended up with this existential crisis, because all this plastic stuff has to go back in this thing. And it didn't. It really didn't for like half an hour at a time. And you're stood sweating in this aisle, going... So that's what it used to be like. I haven't touched a computer in at least 8 years. It's wonderful. I like not touching computers for a living. Yeah, and back in those days, you could buy an entire rack of hardware and have that entire rack of hardware go out of warranty before you'd got into service. Because Linux, lol, and hardware, and like really, it used to be like that. I wish this was a joke. I really wish this was a joke. So, I'm going to do a timeline. I haven't got a montage, sorry, but let's scroll back to summer 2013. Yelp was just starting to think about AWS at that point. They bought another startup called SeatMe. Significant parts of SeatMe survived till 2024, because legacy tech is like that. In summer 2013, running analysis jobs for Yelp had become insane, because Yelp was growing too fast, and remember, it took 3 years to get servers into production. So the analysis jobs literally wouldn't fit on the servers, needed more servers. Okay, sure, just spend, light a suitcase of money on fire, get a direct connect to AWS, throw all the data in S3 and use MapReduce. And that was a big solution, and also was something that could just be moved quite easily. You just light a suitcase of money on fire, it's fine. Cool. And about that point, there were also like some EC2 machines that we were going to try running services for the SOA on. And there's a puppet master that someone had like manually launched and manually set up. And those machines were manually launched and manually set up, and someone had picked their IP addresses specially. And there was a load balancer config that had been manually written with a list of all those machines in. It was great. So when I started about this situation, Puppet 0.26, which was massively out of date by that point. So we initially did Puppet 0.26 to 0.6 to 0.7, did a load of work on machine config, machine provisioning, did a load of work on like service configuration and distribution and abstraction, just made everything not suck as much. We ended up building an entire service mesh, because these load balancers that I was talking about, turns out that if you try and drive 10 or 20 gigs of traffic through one machine, it doesn't have a great time most of the time. So we took a product from Airbnb at the time, and built that into like a V1 service mesh way before anyone else was doing that. And that had the novel concept of running a load balancer on every host, distributing the load. Turns out you go fast forward 10 years, that was a terrible idea. I'll tell you more about that later. And we built out a systems orchestration framework, a discovery framework, a new monitoring system. Like, we just lit everything on fire and threw it away, basically. Because what had worked in a data center was not going to work well in a cloud. So scroll forward a year, summer 2014, SmartStack, our service discovery mesh, was being used, all via HA proxy, so all kind of new idea, old technology, but it worked amazingly well. We did conference talks about it. And then, 2015, Terraform. We started about 0.6.1. I think the first release of Terraform that was actually given out was 0.5.3. At this point, we already had the problems that Terraform was solving, because we were going into new AWS environments and provisioning things, and people had been clicking in the console, and it was all bad, and everything was inconsistent. And so somebody thought it'd be a great idea to like squint and look at Puppet and go, well, this like gets a bunch of information and maps it to like a state of the world and then makes changes. So I could go and do that with AWS and Puppet. And I wrote a whole Puppet provider that would go and manage your AWS environment. And it was slow, and it was terrible to debug, and it was awful, but slightly less awful than clicking through the console in 6 different regions and 4 different environments. So that was a mistake. I should have made someone else write that. And they did. So we stopped that nonsense and bailed pretty quickly. Actually, Puppet Labs took my crappy code for it all the way and wrote the same thing and then published it and went, cool, you can automate your AWS. I was like, cool, suckers, have fun. Yeah, so Terraform was pretty revolutionary. Definitely had a revolution with Terraform. Quite quickly. It's going to happen, right? I mean, I talked at the first Hashiconf, and I dropped this as a slide, and they didn't invite me back. Who'd have guessed? It turns out that with new tools and great power comes great responsibility. And if you automate the creation of a data center, you have also automated the destruction of a data center. And I'm sure that we've all learned this lesson. I hope most of you have not learned it in the dramatic way that I did. So also in 2015, our great ideas, we wrote our own metric collector because that seemed like a great idea that there wouldn't be an open source thing that would do that already. 2016, we threw all Terraform away because we'd done it wrong, because nobody knew how to do Terraform in some maintainable way, and we rewrote it. It sucked less. At that point, you still had to use VI on the state file to make things fit into your existing infrastructure, but we did. And a lot of sed and some awk, maybe some Perl. It worked. Winter 2015, we announced our own platform as a service, internally. That was simultaneously a great idea and a terrible idea, because we got some bits of it really right and some bits of it really wrong. 2016, early 2016, we had a lot of data and a lot of data streaming, and so we announced that we open sourced and entire data pipeline thing, and it was all terrible because again we hadn't done it before on a big scale, so we made loads of mistakes. Spring 2016, we were auto-scaling services. So we actually had this service mesh, and we had services, and when there was more loads, then we would run more copies, which was pretty wild. You didn't have to phone someone up. No longer had to phone the software rep and go, can I have a new server, please? Because, I mean, you could get servers from software by clicking, but they charge you list price, which was 10 times more than if you phoned some dude in California. I don't know how that worked, but it did. Cool, so let's skip forward for a bunch more history. You don't recognize this, it's one of the best tweets, literally. So spring 2017, we had got this dynamic scaling thing working really well. We had started parallelizing our tests, and so we did the whole thing of, my tests are slow, what's the fix? Throw 1 million computers at it. Which is not a great fix, but is a pragmatic fix. And we got to the point where we were launching over 1 million Docker containers a day back in 2017, just for testing. Also 2017, we had got dynamic capacity, so we started our website slow. Well, okay, let's start rendering multiple parts of the page on multiple computers and then draw them together. Again, we'll throw computers and throw money at the fact that our code's shit. It worked quite well, as a stopgap measure, of course. 2017, we thought it was a really great idea about writing custom Terraform providers, so we did a bunch of that. Again, it's a terrible idea. Thankfully, in most cases, we managed to sidle up to the vendor and go, here's a piece of shit. And that worked pretty well, actually. These days, not so much, but that is a good trick if you can pull it off. And 2017, we were we had used Mesos for all of our orchestration because Kubernetes didn't exist back in those days. And autumn 2017, we were busy talking at MesosCon about all of our successes, whilst also working on burning Mesos because it clearly wasn't the future. Kubernetes was going to be the future by 2017, and etc. We bought another couple of startups. I ended up going and working for those and working on take someone else's complete architecture and move it into our systems, which was an interesting journey in working out what we got right and what we got hideously wrong. Winter 2017, we'd started, one of the most important things to take from this talk is that our jobs are getting more and more abstract. Like, if you are a sysadmin, AWS has almost replaced you. You know, if you're a traditional, I edit things in /etc using VI, you're not going to have a job for all that long. And that is going to continue. Like AWS are now offering managed Kubernetes, they're offering managed Flink, they're offering managed Kafka, all these things going up the stack. So in our careers, we are going to have to go up and up and up the stack and never touch computers again. And that's good. You know, and a bunch of other things that are like dragging yourself through broken glass at the moment. In 10 years' time, you'll not have to do them. The fact that we used to do them will be silly. And if you want to base your career around that, you're probably not going to have a great time. So you're going to see things like that, like SFN, step functions, takes a bunch of logic out of your application. Everybody who has worked as a developer has at some point written a state machine really badly. We've all done it. And some people who've done it 2 or 3 or 4 times have written one not all that badly, and it's more complicated than you think, like most programming things. SFN makes this not your problem, it makes it AWS's problem. And if you can deal with the constraints on that, it's a good thing. 2018, we're using loads of spot fleet at this point because the spot prices would do this. So you could get your AWS for about 20-30% of what you would pay list by using lots of spot. This is no longer a thing. Or spot fleet is still a thing, but running 3/4 of your infrastructure on spot and shifting it around, the spot market is no longer that volatile, there's no longer that much capacity. You are, for most workloads, you're probably better off using reserve capacity or reserved instances or whatever they're calling it this week. But spot used to be a big thing, and the fact that we could do spot was this massive progression from, okay, I'm editing the config on the first load balancer, I'm editing the config on the second load balancer. 2009-ish, production engineering. We renamed the team to production engineering because that made sense. It was none of the terms that anybody else was using, so sounds good. Late 2019, we threw the first service mesh away, replaced that with Envoy. Spring 2019, our 2nd generation cluster autoscaler came out because we built an autoscaler. It was rubbish. We built a second one. That was rubbish too. Winter 2019, we had stuff in Kubernetes production. 2019, we were blogging about streaming terabytes of data out of Cassandra into Kafka, into other places. 2019, Sensu, the new monitoring system we introduced back in 2013, that was EOL'd. So we made a good bet, sort of, except the company that maintained that kind of went, yeah, we're not doing it anymore. And the replacement product then deleted all the features that we'd really bet big on. So cool, okay, we're doing Prometheus now, I guess. It happens, it's going to happen. 2020, Flink, so all of our data streaming stuff, that is running on Kubernetes. Winter 2020, Cassandra is actively moving off EC2 into Kubernetes. We've written our own operators. 2021, oh, I forgot to say, back when I started, we had our own search engine that we'd built from Lucene, and then we moved to Elasticsearch, and then 2021, we're moving off Elasticsearch to our own search engine that we built using Lucene, because these things go in search. And also the direction that Elasticsearch, the company, had gone was like, yeah, we do not want to continue investing in this and paying them piles of money for something that is not developing in a way that is useful for real-time search for us. What else? 2023, launched another pass on top of our pass for React apps. That was actually a big deal because making developers write an entire backend application when they just want to deploy some React didn't work so well. Turns out that like, you know, the ground moves under you while you're stood still. 2024, third autoscaler. This time, someone that wasn't us has written one. So it's rubbish, but not our problem, which is good. 2024, multiple metric autoscaling based on that. Also 2024, we're throwing away our data ingestion pipeline, number 4 to do number 5 with DBT. And yeah, let's go back to the agenda. So hopefully that gives you some flavor of how everything changes, and everything like repeats and cycles, and everything changes again a few years later, and how you get it wrong, and you get it right, and you realize that the thing that was right was wrong. Because going back to that, load balancers on the end nodes, it turns out if you've got 3,000 nodes, all with individual load balancers on them, number one, you flatten the host that you're talking to just with health checks. Not so good. And number two, if you have some requests that are really expensive and some that are really inexpensive, and you're using random distribution between 3,000 hosts, you can almost guarantee that the 5 hosts going to issue really expensive requests dogpile one server because they don't know what the other one's doing, right? You can only do least con routing because you haven't got any global visibility. So if you have a service that handles slow requests and fast requests, it does not do well with non-centralized load balancing. And you end up with P99s that are like dog shit because just chance. So yeah, you need to plan. Like we do these projects to improve things, and we plan how we're going to get to the new thing that we're building. What is even more important than that is you need to plan how the hell you're going to get off the new thing you're building when you realize it was a terrible idea. And that might be in 5 years' time. So over the course of 10 years, everything you built in the first couple of years should have gone away. And in fact, if it hasn't gone away, you can look at that, and it's probably because you made a bunch of choices that painted you into a corner, and it's a thing that cannot go away. Congratulations, you created a monster. I've done this. Sometimes that's okay. Often it isn't. So you don't necessarily need to solve every single problem up front. You don't need to know every answer before you deploy something new, but you do need to make sure that you know that all the problems are solvable, rather than just having this ... profit thing. Is like, because I've done that, and you might make profit, and you're like, oh cool, there's no way back, there's no way, we are spending a lot of time keeping this not being on fire, and AWS just replaced all of it. But we can't use that, because literally we've got no path off. So, I don't know if you've heard this, but I've had this broom for 20 years. So 3 new handles and 8 new heads. Is it still the same broom? And if you're the broom's user, the answer is yes. Still got the same interface, still does the same job. You sweep up with it. Is it the same broom? Do you give a shit? No. Like, you don't care if someone's actually changed the broom underneath you. And this, as an infrastructure, as a platform team, this is what you want to be able to do, is to change the engine in the car whilst it's running without the driver noticing. Which is a good trick and quite hard, but if you deliberately design so you cannot ever do this, then you're stuffed when you need to do it. So how we got this right, in our pass we abstracted all the service launch settings, like the number of containers, the size of those containers, etc., into a simple abstraction of YAML files, because of course YAML files. But this worked really well. When we wanted to throw Mesos away and use Kubernetes, we literally just had one file that was Mesos, and it'll run on Mesos. One file that's Kubernetes, it'll run on Kubernetes. Same format. Cool, okay, migrate an application. Move the damn files, commit to Git, it's pushed. So pretty much the migration was, tell teams when we're going to migrate their shit, check with them that their alerts and metrics are good, and we're going to watch this. And if it does this, then we're going to back it out, right? And check that that assumption is good, and you can just do it. And so the platform team was able to change the entire platform underneath the running applications without the users really being involved. A few things, a bit more involvement, but the vast majority, we could just change the platform. And that was really good. That was really, really good. So this is all about one-way doors and two-way doors. I don't know if anybody has heard of this before, but A one-way door, the clue's in the name, once you've walked through the door, you're stuffed. You can't go back. It's like the security at the airport. A two-way door, it's like a normal door. You can just walk back through it. So deploying a stateless web application, that is a two-way door. You can just deploy the old version again. You're fine. Making a database column not null, that is a one-way door. Because if all the code is not good with that, you're going to have a bad time. That's a fairly easy, low-cost one-way door, because you just do the appropriate due diligence. But you can do a lot of things that really paint you into a corner. So some strategies to help with this, you can dark launch new systems. Like launch them, run them in parallel, compare the results. Do that for some significant amount of time. When you're going to turn a new system on, do so, but keep sending data into the old system. And if you have to go back, you can just flip. And yes, that's going to cost you twice as much. But if you turn the old system off and the new system on, and a week later, you find that the new system is like throwing your data away, you're in a really bad place. Like you're in way worse than running the old system for an extra week place, right? So that's one simple strategy. Another example is if you have some derived data, like the average request rate, you're stuffed. Like you can never recreate that. So what you need to do is you need to save every single event that ever happened since the beginning of time, and you can just replay all of time and recreate that derived metric if you need to. There's a bunch of things that you can do so you have some rollback. Like any form of rollback at all is fine. And the rollback is the same as migrate off, basically, because it's roll forward onto the next thing. If you haven't done this, again, you're not going to have problems. Another strategy is a lot of things come as like a bunch of two-way doors surrounding a one-way door. Just split them out. Do all the things that are two-way doors as separate things to the thing that is a one-way door. So you're doing one small change that is the one-way door. And think about rephrasing your decisions or rephrasing your constraints, because a lot of things, when you look at them one way, they are one way. When you look at them a different way, they're two way. For example, a price decrease. You can't increase the price again. Customers get mad. But a special offer, you can have a special offer for 3 months, 6 months, a year, and make the special offer go away again. Okay, so I thought about it differently, and I turned a one-way door that will like have your customers literally leaving into a two-way door that might have your customers complaining a bit, but you told them that it was a time-limited thing. And that's a simple example. A lot of infrastructure things, if you like, how I said, like, if I looked at Puppet and squinted earlier, same thing. Like, if you look and squint and turn your head a bit, maybe you don't have the same problem, maybe you don't have the same constraints, maybe you don't need to solve it in the same way that you were thinking. Platforms, double-edged sword here. Like, platforms are really popular nowadays, and everybody seems to be building a platform. There's a lot of commitment in building a platform, a lot of long-term implications. Like, what are upgrades going to look like for the platform? What's the cadence? 6 monthly, 3 monthly, yearly? When are you going to need your users to do stuff? Like, if you're upgrading a platform every 3 months, does that mean that users need to upgrade their applications every 3 months? Or can they do it twice a year? Or can they do it once a year? Or can they just not do it at all? The answer is they won't do it at all, ever. Abstract as much as possible. The platform team can do the migrations. Like, why would your users care? Because usually the upgrades in the platform are upgrades for you to give you a better time. Your users don't care. If you're being woken up, they don't care. Sorry. Escape hatches. Like platforms, if you can abstract everything, give users like something really simple, so you can then just change the platform underneath them. But you're going to find that some users have got complicated cases, and you can't build a platform for something that you've got exactly one of. That is just a solution. So you need to be able to have a dialogue with your users, and you need to be able to give them an escape hatch and go, well, okay, you can have the Kubernetes YAML and you can crack on. Do your thing, talk to the raw metal or the nearest to raw metal, but there are going to be implications of this, because when the platform moves and you're doing a bunch of super custom stuff, you are going to have to put effort in to move with the platform. And that is the trade-off. And if teams are not expecting this, that doesn't go well. So yeah, we told users, the Flink platform, you can just go and write a Flink app. That went terribly, because Flink comes with its own data store. So we had tens of applications with this data store that we had no backups for, that we couldn't recreate. Cool. How are we going to migrate? We're not. Great. We're never going to migrate them, ever. Have fun. And you've got all these apps, and 5 years later, no one knows why there's a custom app here. What's it doing that our generic apps won't do? Don't know. Okay, cool. Can we move it to one of the generic apps? Don't know. Just solve a halting problem. It's easy. Is what this comes down to. Like, we can't change it. We can't be confident to change it. But it's not worth the team's effort to go and change it. It's our problem. It's our platform. So we shot ourselves in the foot by letting them do that in the first place, because people's expectations were not aligned. If you go to feature development teams and go, "Hi, I need 6 months as your year to do migrations," what are they going to tell you? Not a conversation that you want to have, unless you had the conversation 4 years ago and you have it in writing, and you can be like, well, you agreed to this and you haven't done anything for 4 years. This is the debt. But that's not a pleasant place to be. If you possibly can, you just want to do it for people. That's the point of having a platform. Cool. So, quick survey: who has ever reinvented the wheel, built something that there's already a solution for, just because they thought it would be interesting? Wow, there's a bunch of people who are more sensible than me. That's cool. Who's done it in work time? Cool. I'm glad I'm not alone. Thanks for admitting that. That is quite brave. I don't think I've ever done it deliberately, and I'm not going to ask. I've always conned myself, because I'm a big sucker. I've conned myself into believing there's something special about this project that means that we need to build an inverted index search engine, because there isn't one of those available, right? Or whatever. Next question. Who has fallen for that? Who's reinvented the wheel because they thought they were doing something special? There was something special about their problem or their company or their solution. I'm amazed that's very few people. More people have done it because it would be fun than because there was something special. I don't believe you all. Okay. Who has done that only to discover that you just asked for a square wheel? Like, you just built something that was a terrible idea. Cool, there's more people who've built something. We all love a chance to build things. And as I kind of said at the start, if you don't stay around, you don't get the chance to see if your decisions were sensible or not. In hindsight, maybe it was a bad idea, or in hindsight, we solved it for us, but the industry was going to catch up, like autoscalers. Clearly that was something that was going to be developed for Kubernetes. We just had to wait for the world to catch up while we built 3 of them. But thankfully we knew that, and if we were able to build them in a way that when a better thing came along, we could throw our stuff in the bin and adopt the open source solution relatively easily. And if that's going to happen, you should be aware of this, and you should be deliberately designing your thing as a stopgap so that you know you can throw it away. There's usually cognitive bias here. There are a logical error. Like, we have this magical property that needs to be there in existing systems, but often it's not in the existing systems because it's hard. Like, exactly once delivery for messages. For example, we need exactly once delivery. You don't. You really don't. If you think you need exactly once delivery, you don't. You're wrong. You literally are doing a logical error about the problem that you have. If you think that your design requires exactly once delivery, then either you're working for NASA and you have a NASA budget, or you're wrong. It's that simple. You need to reformulate that damn problem. Because you're just going to shoot yourself in the foot repeatedly and light millions of dollars on fire if you genuinely try and dig into solving that. So again, this is like one-way doors. Reframing your problems differently can make things dramatically easier. if a system that is close to what you want exists already as open source or as a commercial product, they probably are not doing the one feature that you need because you don't need that feature, not because they're dumb. I mean, why? Why would you build a database? Why would you build a message queue? Why would you build a search engine in 2024? I've done all these things. It was dumb every time. Unique problems, however, your users both have and are unique problems. Often what your users think they want is insane. Like it's either it's just flat out insane, or alternatively other technology choices you've made make the thing that they're asking for incredibly hard, and it's not obvious why. And that is just a fact. If you design your system as well as you can and documented the inflection points where you're going to have to, where there's a one-way door sat there, I'm going to have to make a choice when we get to this point. You can choose whether to walk through that point, or you can maybe kick it down the road a bit and go, well, okay, if we do this and this and this, we'll then have data to prove if this thing we're being asked for is worth the effort of writing, and you'll probably actually know what the effort of writing is. Like, okay, sure, we can do that. The entire team will come back in 5 years. Tends to make users not require that feature so much. I can remember when we rebuilt the phone system at Yelp, the first spec, we came back and went, cool, you'll have a new phone system in 8 years. But we need it in 2 weeks. Well, we're not going to have what you asked for then. It's that simple. Another great one was, we need call waiting. And actually, what this meant was, our salespeople just don't check for missed calls and return them, as the little control to do that is not obvious. But actually, that meant that, no, they don't get paid for returning calls. The compensation structure doesn't favour that. Therefore, we're not giving our salespeople any inclination to return calls. Why would they earn less money by returning calls? That would be insane of them. Therefore, of course they're not going to do it. It doesn't matter how obvious you make the thing. But yeah, you don't need call waiting. Call waiting is not going to fix that problem. You just need to pay people for doing the things that you want them to do. That's how it works. You are a cost center, or at least the bean counters are always, or almost always, going to consider you are a cost center. Computers cost money. If we could just get rid of the computers and everything would be so much simple. I mean, let's face it, teaching rocks to think was a mistake. No, in general, we, like all of us, have not done a great job of convincing the bean counters that we add positive value, because we're very bad at measuring what we do. It's like, we made things more efficient, provided this pipeline that saves a load of effort. How much? A load. Okay, how many dollars is that? A load. So, unless you're proactively working to add metrics, even if those metrics are largely based on vibes, even if it's a how much did this suck, a lot to a little, and that's the metric. If you're collecting those numbers, then you can make a case for we are doing things that are making things better. Because even the bean counters understand that making engineers sad costs a lot of money, because engineers are expensive and they quit. So even if your metric is we made the engineers hate us less, that has a dollar value. It's quite easy to take that to a dollar value. Just votes out of 5, how much does it suck? If you get anything more concrete, we actually run less servers, or we're more efficient, or some actual numbers and not just vibes, even better. But just metrics that are vibes, that works for selling your worth. Another thing that is a mistake that everybody's made is cost accounting. In the cloud, cost accounting should be easy, right? Except it isn't, because you build this platform, and this platform puts everything in an S3 bucket, and cool, the platform is the cost. Very, very, very easy to do. You need to be building things such that cost and who done it gets tracked through. We had a big problem at Yelp because we had a third-party metrics provider, and we ended up in the place where literally 50% of our metrics as far as we could tell, nobody used them, but because nobody used them, nobody would allow us to delete them, and everybody's afraid someone might use them, therefore we couldn't delete them, and therefore, cool, so we're spending $500,000 a year for data that we know we don't want. That's really smart. Yeah, like just having not thought about that at all and just put everything in one bucket, when it comes time to go through the bucket and work out whose drops of water is whose, it's all drops of water, you're gonna have a bad time, right? Cool. So that's, yeah, S3 buckets literally can be a big problem. Cost accounting, platform usage. Don't generalize anything. Like literally solving the general case leads to this nonsense. Which, come on, everybody's system looks like this, right? Legit. Including the data engineers getting excited to do that. If you don't have two cases, like literally now, do not make a generic thing. Make something that solves the one case that you have and has extension points. You know you haven't painted yourselves into a corner. You're confident that it can solve more problems in the class or can be made to, but don't go and solve them because you'll just get it wrong. It's very, on the other hand, if you're looking at a system that already exists, it's very easy to go, okay, well this new system that we're thinking of designing is much better, much prettier. It will be a quarter of the code and twice as efficient, and it will solve 80% of today's use cases. And the other 20%, ... Okay, cool. You now have two systems forever. You've made a second problem. You haven't fixed anything. You literally haven't fixed anything. Cool. Slack, not actually the company that uses to share CapEx. Slack time. You need to allow people to clean up, to remove debt, to document things, to do experiments, to shave sharp edges off. I have seen it again and again. I've done it myself, where you plan what you're going to do for the next week or month or even worse, year. And what you do is you work out all the projects that you'd really, really need to do. And you're like, okay, shit, we have 2 years worth of projects to do next year. All right, let's kill 50% of them. Cool, all right, that's what we're doing, the most important stuff. No, wait, because you've got on-call, you've got holidays, you've got people being run over by a bus, you've got the pandemic, you've got like random stuff hits. You cannot allocate one project per person per year. I mean, A, giving a whole project to one person, only one person, that is a terrible mistake. And B, assuming that people are going to 100% work on projects, bad idea. Even Google says 50% of people's time, project work, the best case. Best case. Are you more efficient than Google in your org? Probably not. So you should probably be allocating, I don't know, 30% of people's time, 25% of people's time to doing project work. And that means that people will only be working at about 130% most of the time. Expectation management. This works both ways. So if you build a platform and want people to use it, it has to like work and be up and stuff. It has to really, preferably it has to solve users' problems. In a great world, users would want to come and use your platform. You wouldn't have to like push it as this is the way we do it at our company. On the other hand, you can have expectations of users, and you should have expectations of users, and you should document these to say, look, we are going to do a major upgrade every year, and we are expecting you to put X hours of development in per thing you deploy on this platform for maintenance every year. Because all sorts of things happen, like, well, let's say just org changes. Some bunch of engineers builds a system, and they put it in production, and then they leave, go to Netflix or whatever, and then the org changes, and that system ends up owned by some other team who have never touched this before, know nothing about it, and you're like, okay, cool, so we have the upgrade that we agreed. No, you agreed with whom? And yeah, I agreed with a bunch of people who are gone. That sort of agreement needs to not just be like handshakes, it needs to go down black and white. Okay, so learning as you go. Postmortems. Having a section in your postmortem template called lessons learned, bad idea. That's where lessons go to die. Lessons learned by this engineer. We remove that from the postmortem template, not a good idea. Everything that is axiomatic, that you assume that everybody knows, should be written down. The fact that everybody knows it is not going to be true in 3 years' time. And you're going to be really confused when you're literally talking past someone because you've got completely different assumptions. You can then discuss the differences to the standard rather than having to litigate the standard again and again and again. Retrospectives. I'm not actually going to say much. If you're not doing retrospectives, you are missing out. You are missing out a whole bunch. They are one of the most effective tools to make teams effective, to do the right work, to do the right work in the right way. Leading change without authority. You end up wanting change in your org and not wanting to mandate it. You can do a lot of this by just cheerleading and a dog and pony show. Literally, we defined a bunch of infrastructure criteria, security, reliability, blah, 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 and then levels of each of them. And just by measuring our own stuff, we've got to check on, okay, what is a sensible level that we should ask for the org? Or if we could ask for, we would ask for. Okay, and then go and talk to some teams next to you and get them to fill in some stuff for their systems. Okay, do their systems look okay? Okay, go to some random teams where you just happen to have connections, get them to fill some stuff in. And you should be able to get some metrics out to go, okay, people who have these sorts of standards have this many outages. People who have this sort of standards have these many outages. Quite easy. Again, it can be vibes based, but you can then sell it, and you can then sell it in a, you should all be using this, it would make your lives easier, and you don't need any mandating to do it. Culture. Definition of culture, it's the way things are done in an organization, including norms, rituals, and unwritten rules that influence how people behave. I would suggest that unwritten rules are a bad idea. Just write them down, even if everybody knows them. And you can't make significant changes in how everybody works without authority, but it's best to drive change by enthusing engineers. And the way that you do this, the only way you can do this, is by communication, and communication on multiple levels. So having some organization-wide, we are going to try and do this in 2024 goals, means nothing to the people working on dev tooling. They need to fit into the org strategy, we are doing this, and to fit in, how my team fits in is 5 levels down. And you need those comms at all of these kind of levels. So the board of directors and CEO are talking up here, and team leads and tech leads are talking down here. You're going to need all of these things, which is a lot of time and unfortunate, but especially now that we don't have those over the desk conversations and everybody's remote, this stuff needs writing down, otherwise there will be gaps. And collaboration. If someone's going to make bad choices and bad architecture, they need to come and talk to you. You need to have trust and collaboration. You're going to help them, not shout at them, just help them do their thing. And that is how you end up not going, oh shit, well, I wish you'd spoken to us 6 months ago. So this is where you need that slack, because when someone does come to speak to you, you need to be able to go, oh yeah, of course we'll add that feature. And just do it, because you've got the slack to do it, and you're like, okay, someone needs this, if I can add it this week, they will use the right thing, otherwise we'll build a bunch of tech debt. And having that slack allows you to do that tiny amount of work that avoids this much tech debt. Release blocking. You need to be very firm and have agreement, at high level, what is acceptable to go into production or not. Because if it's a bit slow or a few too many errors, but it's an important feature, so that's a slippery slope. You're screwed. You have to stop to address quality. And migrations need to be pragmatic. You cannot spend all your time upgrading operating systems. I learned this when we had a team member quit, and in kind of the exit interview, they're like, what was wrong? And they're like, I've been here for 18 months, I've upgraded Linux. That's what I've done for 18 months. I am leaving before I die. Myself. Yeah, you need to design easier paths on, easier paths off things so that inevitable migrations have minimal coordination between teams. You will have two platforms at once. That is inevitable. You should not be forcing people to move and having these mandatory migrations until the new platform has won. And it's like just the last few people that you're shuffling onto. Because that you can sell. Like, you have a significant risk, nobody knows about this old thing that you have anymore, and your thing makes lots of money, is a selling pitch, whereas you need to move all the things so that I have a better time, not a selling pitch. I think that's about it. Yeah, I've talked about you need Slack to tackle unexpected things, you need excellent customer service, high quality platform. Toil reduction is going to take up a bunch of that slack. Automating small bits, documenting things, adding small features, fixing runbooks. When people come to you and ask dumb questions, spending time to explain to them until they suddenly see, and then working out what the missing assumption was in the docs. But you need to be pragmatic. Sometimes you just do the boring thing and you don't automate it because that has business value. That's fine. Automation can just literally be writing down the steps so that anyone can do it. Like, that is better than where we started. You don't have to have written a script or whatever to make things better. As long as it's going to suck less for the next person, you're doing it right. That's it.
Brilliant. Making things suck less for the next person, I'm all for that. So, does anybody else know what a DL360 is? No, I thought you got some bank looks there, but I'm here with you. I serve the scars. So, yeah. Brilliant stuff, Tom. Thank you so much. Thank you also to Nathan for a brilliant talk. Thank you to everyone for coming.